this next question, this is on page 6, number 11. If 7i, this right here, the function at 7i is 0, means that 7i is a 0. Therefore, negative 7i must also be a 0. Which means x minus 7i and x plus 7i are factors. When I multiply these together, I get x squared. The plus 7ix and the minus 7ix cancel, and I get negative 49i squared. And this just becomes plus 49. So x squared plus 49 is a factor. And there must be one more 0, because this is an x to the third. So that's going to obviously be the smallest real 0. So I'm going to come up here to this space and I'm going to divide x cubed plus 4x squared plus 49x plus 196 by x squared. I'm going to need a placeholder 0x plus 49. Focus on the first. X cubed divided by x squared is x. Multiply this out. X cubed plus 0x squared plus 49x. Since I'm subtracting, I change my signs. Both of these cancel, and I'm left with 4x squared. And you won't be able to see this, plus 0x plus 196. Focus on the first. 4x squared divided by x squared is plus 4. Multiply it out. 4x squared plus 0x plus 49 times 4 is 196. So when I change those signs, I end up with 0 as my remainder, which I expected because I knew it was a factor. And I'm looking for the smallest real 0. So since x plus 4 is a factor, I can find the 0, subtract 4. X equals negative 4 is the smallest real 0. Let's go to number 13. How many real solutions, that means x-intercepts, that I can see on a graph are there to this polynomial? Right? We know that there's 3 total solutions. So there could be all 3 real, or we could have 1 real and 2 non-real. Because remember, our non-real solutions come in pairs. So let's turn on our calculator, go to y equals, and put in x to the third plus 2x squared plus 25x plus 30. I have a standard window. Let's graph it. All right. I only see 1 real solution. So 1 real solution. Now if I'm thinking, well, what if they're somewhere farther away? Well, then let's back up and look. Negative 50 to 50. Negative 50 to 50. Nope, still only hits 1 time. I don't see it hitting anywhere else. Just going to put my back to a standard window. So I did not see it hitting anywhere except for that one place. So 1 real solution. Right, number 14. Let Q equals 7 plus 3i and D equal 4 minus 2i. What is Q minus 3D written in A plus BI form? So Q, which is 7 plus 3i, minus 3 times D, which is 4 minus 2i. I can't do anything with that. That just is going to be 7 plus 3i. This negative 3 is going to get distributed. Get negative 12 plus 6i. Get my like terms together. 7 and negative 12 is negative 5. 3i and 6i is 9i. Number 15. Let w equal 5 plus 11i. K equal 3 minus 7i. What is w divided by k? So 5 plus 11i divided by k, 3 minus 7i, in a plus bi form. Well, remember, I'm not allowed to have I in the denominator, so I have to rationalize by multiplying by the complex conjugate. First number always stays the same, and we change the second number. Same thing in the numerator and denominator, so that we're just multiplying by 1. Now I'm going to FOIL. 5 times 3 is 15. 5 times 7i is 35i. 11i times 3 is 33i. And 11i times 7i is plus 77i squared. In the denominator, I have 9 plus 21i and minus 21i, and then negative 49i squared. Those cancel. This is going to become minus 77, since I squared is negative 1. This is going to become plus 49, since I squared is negative 1. So I've got 15 minus 77, so I'm going to use my calculator here. 15 minus 77, I get negative 62. So you can kind of see both. Okay. 35 and 33 is what? 68i. And 9 plus 49 is 58. When I separate this, I get negative 62 over 58 plus 68 over 58i. I'm going to put each of those fractions in. Negative 62 divided by 58. Math, enter, enter. And I get negative 31/29 plus 68 divided by 58. Math, enter, enter. Plus 34/29 I. Okay. So that was page 6. Now let's go on to page 8, where we're skipping 3 and 5. Asks, this equation has how many non-real solutions? So those are the ones we can't see on the graph. We know that there's 5 total because this is an x to the 5th. So I need to look at my graph, x to the 5th minus 5x to the 4th plus 3x to the 3rd minus 6x plus 10. When I graph that, okay, 1, 2, 3 are on the graph, so I have 3 real, which means I must have 2 non-real. Sorry. So hopefully you could see that. I have 3 real solutions, therefore 2 non-real. Okay, next question asks me, what is the remainder when this polynomial is divided by x plus 7? Since I'm dividing by x plus 7, I can use the remainder theorem. I'm going to let x equal negative 7 and put it into the original. And and I will find my remainder. Sorry. 7 times negative 7 to the 4th minus 2 times negative 7 squared minus 9 times negative 7 plus 1, and I get 16,773. And notice I put 7, I put that in right, times negative 7 to the 4th. I'm just double checking it. Negative 2 times negative 7 squared minus 9 times negative 7 plus 1. Yes, that is correct. Next, number 4, I'm told that 6 minus 9i is a 0, which means 6 plus 9i is also a 0. What are two factors? Well, one factor would be x minus the 6 minus 9i. The other would be x minus the 6 plus 9i. Distribute, and I get x minus 6 plus 9i and x minus 6 minus 9i. Here are two factors of the polynomial.